Hi guys, what's up? This is Darshan. Welcome to my YouTube channel Civil AJ Academy. In this video, let us discuss about the Geotechnical Engineering AJE objective. So this is the quote of the video. You don't need a new sunrise to start over. You only need a new mindset. So question number 1. In this question, they have asked you to arrange based on the mode of transportation of the soil. So you can see here that lacustrine soils are the soils. Okay, so they are deposited at the bottom of the lake. So we can go with the option 3 here. Alluvial soil. So alluvial soils are the one they are transported by the running water. So we can go the option number 2. Aeolian soils are transported by the wind. We can go the option number 1. As well as the marine soils are deposited in the seawater. We can go option number 4. So by looking these 3 to 1, 4, we can go with the option B. So therefore the answer is option B. So here we need to discuss also some other special types of soil. So you know that aeolian soil, what are the example for the aeolian soils? Example for the aeolian soils are nothing but the losses as well as the sand dunes. So losses and sand dunes. You need to know the important fact of these two soils. These two soils are called as a collapsible soil. And when you compare the loss as well as the sand dune, even though both of them are transported by the wind, which is called as a aeolian soil, sand, this sand dune is there. This is more collapsible than the losses. Sand dune is the one, even though both are collapsible soil, this is more collapsible soil. So more collapsible than the losses. Again, we need to know other some types of soil. They are nothing but we call it as a marl, muck. Okay, marl as well as the muck, MUCK muck. So what is a marl? So marl is a fine graded calcium carbonate soil of marine origin, which is found due to the decomposition of the animal bones and aquatic plants, and it is greenish in color. So we call it as a marl is from marine origin. From marine origin. We can call the marl is from the marine origin. It means it is a fine grained soil containing this calcium carbonate, which is obtained due to the decomposition of the animal bones as well as the aquatic plants, and it is from the marine origin. And again, we need to know what is the muck. What is the muck? Okay, so muck is a mixture of, it's a mixture of inorganic soil and black decomposed organic matter. Organic matter, because muck, what is a muck? It's a combination or a mixture of inorganic soil with the organic matter, then we call it as a muck. There is another soil, another word of the soil, that is nothing but calci. So what is calci? It's a conglomerate of gravel, sand and clay cemented by calcium carbonate. Means in the soil, it's a conglomerate of gravel, you have a sand, and you have a clay, and as well as the clay, and they are cemented together by calcium carbonate. So this soil we call it as a calci. And again, there is another soil you are seeing here. Then what is the loss? Of course, you know that loss is a aeolian soil, compressible soil. Okay, it is quite less compressible compared to the sand dunes, of course. But when you go with the definition of the loss, so what is the loss? Loss is a collapsible soil of uniformly graded, wind-blown silt, slightly cemented due to the calcium compounds. When it is wet, it loses its cementitious property and became soft and compressible, and as well as a collapse. It means that it's a collapsible, uniformly graded, okay, soil blown by the wind, and it also consists of some calcium compounds. Some calcium compounds. And when it is wet, it will loses its cementitious property, because calcium is the one which is responsible for the binding. It loses its cementitious property, which is due to the presence of the calcium compound, and the soil will become, when it is wet, the soil will become soft, the soil will become compressible, and as well as it is collapsed. Okay, so these are some important types of the soil that you need to know. Okay, so next question. Okay, so in this question, so you can see that the liquid limit and plastic limit of the sample, the liquid limit as well as the plastic limit of the sample, or here in this problem they have given the liquid limit. So I'm writing here the liquid limit 65, they have given 65%, and plastic limit they have given 29, and the percentage of the soil fraction with the grain size finer than 0.002 mm. 0.002 mm is nothing but 2 micron. It's nothing but 2 micron. So you know that any the soil which is lesser than the 2 micron will be the clay. So therefore he has given the fractions of the clay. So therefore I call it as a percentage of the clay particles in the present in the soil is 24. Then he's asking about the activity ratio. So we know that activity ratio is nothing but simply IP by percentage of the clay particle. So what is IP here? IP is equal to, IP is the plasticity index, which is the, what is IP here? So IP is the plasticity index which is obtained by the difference of WL minus WP divided by percentage of the clay particle. So what is WL here in this problem? Liquid limit is 65 minus 29 divided by percentage of clay particles is 24. Okay. So if you do this one, how much you will get? This will become 36. So 36 divided by 24, you will get 1.5. So therefore the answer is 1.5. Therefore the answer is 1.5. See, we need to know something more about this activity number. We call it as activity number or activity ratio. So if this activity number is less than 0.25, then such a soil is called as an inactive soil. Such a soil is called as an inactive soil. If this activity number is lying between 0.25 or equal to 1.25, then we call it as a normally active soil. Normally active soil. And again, if A is greater than 1.25, then such a soil is called as a highly active soil. Highly active soil. Okay, remember this. So if you see the clay minerals, okay, we call it as, like, we have a Montmorillonite. Okay, this Montmorillonite having the activity value. So what is the activity ratio in the Montmorillonite? Is nothing but 7.5. It is highly active. Because of the Montmorillonite, the soil will become highly active. And if you go with the another one, so that is the Colinite. Okay, you know that Colinite is responsible for the zero shrinkage as well as the zero swelling. How much activity value it has? It has an activity value of 0.38. 0.38. Okay, so it has activity value of 0.38. Similarly, we are also having the Iolite. This is another one. What is that one? Iolite. ALLIT. How much activity number it has? It has activity number of 0.5. Just remember these things. This is the background to this object. 7.5, then 0.38, as well as the 0.98. Okay, so next question. So therefore the answer for this one. So what is the answer for this one? So that is option C. Next question. Yes, actually, they have given some parameters like in the pycnometer test. W1 is the empty weight, W2 is the pycnometer plus 1/3 of soil, then pycnometer plus 1/3 of the soil plus remaining 2/3 of remaining water, 2/3 of the water, and pycnometer plus full of water. It has given the weight, and they're asking what is the specific gravity of the soil. So the specific gravity of the soil, the pycnometer test, because we know that pycnometer test is the test which is used to, it's a test performed in order to find the specific gravity as well as the water content. So the formula for this one is W2 by these parameters. The answer is W2 minus W1 all divided by W2 minus W1 minus of W3 minus W. So this is the answer for this object. Okay. So next question. So therefore answer is this one. So next question, a soil sample has the shrinkage limit of, he has given the shrinkage limit. I am writing shrinkage limit as 10%. I will taking 10, and specific gravity is given how much? 2.7 here, and the porosity is asking what is the porosity of the soil at the shrinkage limit is asked. So we know that E is equal to Wg divided by SR. Okay, when SR is equal to 1, okay, just fully saturated, then water content will become the Ws. Water content will become the Ws. Therefore, we can write E is equal to Ws into G. Therefore, we can write that. Okay, so what is that? I want E. So therefore, what is E? So E is equal to Ws. Ws is 0.1 into, because 10% you have to take 0.1 into G is 2.7. So by this you can take the void ratio. This void ratio will become 0.27. Okay, this is the void ratio. Then what is the void ratio? Void ratio is nothing but the volume of the voids divided by volume of the solids. Okay, so from here you can see the ratio that volume of the void is 0.27, volume of the solids is 1. Then what is the porosity? So porosity is nothing but volume of the voids divided by total volume. So from here you can see that volume of the void is how much? 0.27. What is the volume of the, what is the total volume? See, total volume will be always volume of the void plus volume of the solids. From this you can see that this is 0.27. Okay, and what is the Vs? Vs is 1. So therefore it will become 1.27. So what is 1.27? This is the total volume. So take it 1.27. So you will directly get the porosity. So in terms of ratio, so how much you will get the porosity? Okay. So I need to use a calculator. So 0.27 divided by 1.27, you will get, okay, so 0. In terms of percentage means you are getting 0.2125. It means in terms of percentage, because porosity is always expressed in terms of percentage. So 21.25% is the answer for this. So therefore, answer is option A. Next question. Yes, there is an assertion and reason. Okay, so what is the assertion given here? If the water table is very near to the subgrade, you know that this is a subgrade, the bottommost layer of any pavement. Okay, that is a subgrade. So subgrade of the road is there. It is ultimately, if the water table is very near to the subgrade of the road, it ultimately causes cracking of the road surface. Of course, Of course, when the water table, see, this is the criteria that subgrade should always above the water table. Okay, you have to maintain the minimum water table height. Okay, so that the subgrade should not be affected. Therefore, we can write that this is the correct. This is the correct, and it has giving the reason that the consistency of the soil will change from plastic to liquid state, leading to its volumetric decrease. This is wrong, because volumetric decrease will never happen when the soil moves from plastic to plastic to liquid state. So when it moves from plastic to liquid state, the soil will behave like almost when it exceeds the liquid limit, then the soil behaves in the like a liquid. Therefore, its volume will increase. Therefore, so this is not the correct explanation. First of all, if it is increased, then it would be. But so from here, so option A is correct. Okay, option under assertion is correct as well as the reason is wrong. So ಹಾಗಾಗಿ ಯಾವ ಆನ್ಸರ್ ಗೆ ಹೋಗಬಹುದು? So that is A is true as well as the R is false. Option C. Next question. Yes, in a wet soil moss, air occupies 1/6 of its volume. He has given that the volume of the air is 1/6 of the total volume. Okay, and water occupies, the volume of the water occupies how much? 1/3 of its total volume. Then what is the void ratio? We know that void ratio is nothing but volume of the voids divided by volume of the solids, of course. Then what is the volume of the voids? Volume of the voids is together volume of the air plus volume of the water divided by volume of the solids. When you add together 1/6, okay, so what is 1/3? 1/3 is nothing but again 1/6 plus 1/6 divided by, okay, we need to know, so times of volume this is. Okay, so how much you will get? You will add this one, it will become 3/6, that is 1/2. So 1/2 times of the volume. If it is 1/2 times of the volume, because we know that the total volume is nothing but Vs plus Vv. Okay, if this portion is 1/2 times of the volume, then if it is V, then it is Vs. Okay, if you do, what you will get? Vs is equal to again 1/2 times of V. Okay, remaining should be off only, so I'm taking it as a off 1/2 times of the V. Then how much you will get? You'll get the void ratio as a 1. Therefore the answer is 1. Therefore the answer is simply 1. So let's go with the next problem. Yes, lacustrine soils they are the soil which are deposited in the lake beds. Okay, they are called as a lacustrine. Lacustrine means lake beds. Therefore option is, the answer is option B. Next question. Okay, soil sample is having the specific gravity of how much he has given in the problem, 2.6, and what is the void ratio? Void ratio is given 0.78. Okay, the water content in the percentage required to fully saturate the soil. So how much water is required in terms of percentage in order to fully saturate the soil? Okay, at that void ratio, in the given void ratio for fully saturation, what should be the W in that void ratio is asking. We know that is equal to Wg by Sr. So Sr is equal to 1 here. So therefore is asking the water content. So water content will become E by G. In terms of percentage, we have to multiply it by 100. So what is here is 0.78. What is G here? G is 2.6. If you multiply 100, okay, if you simplify in terms of percentage, so this will come as, okay, so this will come as 30%. 30%. So therefore option is B. Therefore option is B. Okay, so next question. Let us move with the next question. Okay, so a dry sample, a dry soil has a mass specific gravity. So mass specific gravity means GM is 1.35. Okay, and specific gravity of the solids G is given how much? 2.7. Then he's asking what is the void ratio will be. So what is the void ratio? will be? What is the void ratio will be? So what is the, first of all, what is the void ratio? So void ratio is nothing but volume of the voids divided by volume of the solids. Volume of the solids. Is it not? Yes. So therefore, so he's asking what is the void ratio. He's asking what is the void ratio. So we can do it by other methods also. We can do it by other methods also. I'm using the method. So that is shrinkage limit concept. That is shrinkage limit is equal to 1 by gm minus 1 by g. If you use this one, that is 1 whole divided by 1.35 minus 1 whole divided by 2.7, the given problem. So what is the shrinkage limit you are getting? Okay, so the shrinkage limit is nothing but 37%. That is 0.37 I'm getting. Okay, 0.37. We know that at shrinkage limit, the degree of saturation is 1. Then I'm using the concept that E is equal to Wg by SR simply. Okay, so SR is 1, W we have find out, that is the shrinkage, because SR is equal to 1. W will become Ws, therefore it is 0.37, and as well as the value of G is given 2.7. If you multiply, simply you will get the E value is equal to 1. Therefore answer is equal to 1. So option B is the correct answer for this question. This can be further solved by other method also. I'm preferring this method. Next question. Okay, so a clay sample has a void ratio of 0.5 in dry state and specific gravity this much. What is the shrinkage limit? Again, same shrinkage. At shrinkage limit, what will happen? Degree of saturation is equal to 1. Okay, so yes, so we know the formula. So E is equal to Wg by SR. So when SR is equal to 1, just fully saturated, then it will become the liquid limit will become the shrinkage limit. Sorry, the water content will become the shrinkage limit. So therefore, what is asking the shrinkage limit. So shrinkage limit will be equal to E by G. In terms of percentage, it has to be multiplied by 100. So what is the here? So what is the here? He is a 0.7. What is the G here? So G is equal to 2.7. Okay. So if you multiply it by 100, how much you will get? How much you will get? So you will get this question for this question. How much? 0.5 divided by 2.7. So you will get 18.5% is the answer for this. So option C. So option C. Okay friends, that's it for the today video. Stay tuned with my channel for more updates. Thank you.